well, what are sets? And you might be able to go further and say, well, sets are objects in a certain category. But I deny that there's a fact to the matter as to what they are. And that's ontological relativity. Relative to taking some ontology as fixed, you can say what other things are in terms of basically the most you can do is preserve structure. So that's where the structuralism comes in.
Welcome everyone to today's interview, where I'm very pleased to welcome Professor Michael Resnik. He is Professor Emeritus at UNC Chapel Hill, and his work is focused primarily on the philosophy of mathematics, logic, and also on decision theory and some related topics. His books include, among others, Mathematics as a Science of Patterns and Choices: An Introduction to Decision Theory. He also has numerous published articles. Feel free to add anything. But with that, welcome and thanks so much for being here, Professor Resnik.
Thank you. I'm glad to be here. And I think your introduction was great. So go ahead and ask some questions.
So I want to start talking about stuff to do with mathematics and indispensability. So this is something developed and popularized by Willard Quine. And the general idea of indispensability arguments for the existence of mathematical objects is that, well, we should accept the ontological commitments of our best theories, our best scientific theories, and mathematical entities are among the ontological commitments of our best scientific theories, and so we should accept mathematical entities. We could expand on this with, by considering his holistic commitments and naturalism and more general stuff to do with ontological commitment and so on. But that's the basic idea. So could you talk a bit about your current thinking on the force of this style of argument and maybe how they might be forceful even if we're scientific anti-realists?
Yes. The argument, at least in the hands of Hilary Putnam, was designed to respond to nominalists who also wanted to be scientific realists. And he basically said that they were involved in some kind of inconsistency in affirming science while denying mathematics. And my form of the argument depends upon analyzing the way mathematics is used in science and seeing that to use the mathematics, we have to assert mathematical statements. And in so doing, if we assume the usual theories of truth and ontological commitments that most people who are participating in the debate do assume, then we see that we are thereby committed to the existence of mathematical objects. And that is the case even if we are doing, in doing science, we are using idealizations or theories that we know to be false. I think I can give you a simple illustration. The mathematics would be very simple, and because of that, very easy for the nominalists to eliminate it and argue that this math is not indispensable, but I think it's best just to take a simple example. So suppose you're considering whether to make a trip from New York City to Washington, D.C. And for some crazy reason, you also consider going to Pittsburgh first and then driving to D.C. And somebody points out to you that that would be a much longer route. So how can we establish that? Well, we assume that New York City is one point, Pittsburgh is another point, and D.C. is a third point. Then, given any 3 points that are not collinear, it's a truth of geometry, and we sort that. There's a plane containing them, and a triangle in that plane that they are the vertices of. Okay, so we've already idealized and treating, introducing lines connecting Pittsburgh and New York and D.C. and thinking that we're dealing with a plane. And then we cite a theorem of geometry that any two sides of a triangle, the sum of any two sides of a triangle, is a greater distance than the third. So if you take a trip where you go on two sides of a triangle and then go on the third, you're doing a longer distance than if you just go from along the third originally. So that has committed us to some mathematical entities, namely points in a plane. Now, if we want to get more precise and know what the exact distances are, then we do something like introduce a coordinate system and calculate distances on that coordinate system. But that's going to be more mathematics. But I think I hope this is enough to illustrate my point, that in so doing, we had to assert several mathematical statements, and they did with Quine's theory of ontological commit us to mathematical entities, namely those geometrical ones I mentioned. Now, there are lots of ways that people have attempted to avoid this argument, and what I'm offering here is not a response to those ways of avoiding the argument. One way is to say, well, geometry is not mathematics, that's physics. We're talking about a theory of space here. And actually, that's where my structuralism comes in, because the structural assumptions that are needed are just as rich as a two-dimensional space of real numbers. Another kind of approach is to say, well, when you assert something, you're not committed to its truth. And I don't have an answer to that. It just seems like a silly thing to say. But there are people who would say, look, when scientists do mathematics, yeah, they make those assertions, but they take them back later. They don't have to There's somebody named Joseph Malia that has said this. Another tactic is to say, you can use existential quantification in ordinary language. You can say, there are numbers, without committing yourself to the existence. And my colleague at UNC, Thomas Hoffaber, would say that. Jody Izuni would say that. I don't have an argument that could convince them. I don't have a way of arguing from premises that they would accept that they're wrong. And I find it one of the frustrating things, one of the kind of dead ends that I've run into in my old age. So I think that's all I'd say on this at this point.
Yeah, so a lot of great stuff there. And I wanted to touch on one thing. You kind of preempted sort of a question I was thinking about asking, having to do with that last approach there. Like what if we end up saying something like, or someone were to adopt the view that the sort of ontological commitment or reference or whatever cannot be read out from the theories in this way, or the sentences we assert sometimes, because like you might think, like we're going to deny that the truth of these theories or the sentences that involve these like singular terms or bound variables requires the existence of objects denoted by or which satisfy those terms. So I might think maybe there's like rules of the game, so to speak, which determine the truth of sentences in certain domains. And maybe in most usual contexts where that involves singular terms, it requires like objects that they denote. But in mathematics, maybe it doesn't. Maybe in ethics, it doesn't. Maybe another. I don't know if this makes a whole lot of sense, but like, I don't know. I guess it has to do with giving up on certain Quinean approaches to ontological commitment.
Absolutely. If you don't go along with that, then we come to a dead end, really. He's been very influential, but people like Izuni and Hoffaber are going away from that set of assumptions.
Right. Yeah, and then so going back to the previous stuff, like, and then to be clear, how could this be useful even to a scientific anti-realist? I mean, you had a sort of pragmatic version of the indispensability argument that you had developed, and I don't know, is that something you would still endorse, or what do you think about? How would you describe that?
Well, I feel more confident in just pointing out the way that mathematics is used in science and what it commits one to. How you go from there requires all sorts of additional assumptions that, if you assert something, then you're committed to its truth. And you ontologically commit yourself to the objects it presupposes. So I'm going. I guess in my book, where I try to formulate it as an argument, I guess you could say you can do science only if you're going to assert some mathematics and thereby commit yourself to mathematical objects. Then we need another premise. We want to do science. Therefore, we have to commit ourselves to mathematical objects. and I'll leave it at that.
Yeah, and that's supposed to, or the thought, part of the thought there is that gets around certain issues, where someone might say, well, but what if, we think that these theories are maybe strictly speaking false? Well, even if they're false, the kind of discussion and, even talking about them and engaging in this sort of discourse involves certain mathematical commitments and something like that.
Right.
Is that roughly how it goes?
Right.
Yeah. That's interesting. And then, so another approach, another kind of nominalist or fictionalist approach is, like, last year I had Mark Balaguer on to talk about his book, Metaphysics, Sophistry, and Illusion. And an approach that he considers in response to indispensability arguments, which I find kind of compelling anyway, is to, this is not original to him, obviously, but is to dispense with the truth, strictly speaking, of these scientific theories. The theories are false insofar as they commit to, like, these abstract mathematical entities, but they're, correct, quote unquote, in the respects that we typically care about. They get the physical ontology right. They make the right sort of, enable us to make the right sort of predictions, empirical predictions, like the positions of particles and so on. There's this illustration, like, if the mathematical entities in this separate realm happen to exist only every other day, right, then our best scientific theories, supposing they're, like, otherwise true, would be true only every other day. But it's not clear to me that anything of, like, empirical or typical scientific investigation would change at all. I don't know. What do you think of this sort of approach and, like, the assumptions it makes, and just, like, the idea of giving up on the strict truth of these theories? That makes sense.
Well, I think the approach is silly. But I also think that it's irrelevant, because I've already said that even if you believe that the scientific theory is literally false, you're still, in developing it, you're still committed to mathematics. And in particular, you can think of, you're making a deduction. And if you want, what you end up getting is something like a conditional statement. If mathematics is true, then such and such observations will be observed, or this will explain so and so, or the rocket will reach the moon. Okay. Well, what you want is the conclusion the rocket will reach the moon. Well, you can't get that conclusion unless you can do a modus ponens, so to speak. And you got to do that, you have to assert the premise that mathematics is true. So that's why I don't think the argument is relevant. I also think it's silly to speculate about what the empirical world would be like if there were no mathematical objects, because we can't really say what we're talking about. In describing the empirical world, we have to use mathematics. And it's not clear what, if you have this idea of taking the empirical world and somehow removing the mathematics from it, we're not sure what would be left with. And that was one thing that was so impressive about Hartree Field's program, Science Without Numbers, because what he was trying to do is show that we could have a description of the empirical world without using any mathematics. But what he was doing was using geometry, and as I said, that to me that is mathematics.
Yeah, so there's a few things to touch on there. I mean, I guess, yeah, because there is this worry that, like, well, I sort of suppose that we can talk about the sort of universe absent the realm of the mathematical objects, but like, there's a few things that might be said there. I mean, one is, I don't know, it just seems like if these are really sort of like a separate, they don't interact with the world, they'll exist in some kind of Platonic sense. It seems conceivable to me that, like, you could have the universe and the objects, or you could have the universe and not the objects. Now, that case where this universe and not the object may have some potentially troubling implications for, like, how we talk about the universe and so on, maybe. But I don't know, just the thought that you could have just the universe alone makes sense to me, but I don't know, maybe there's still some troubling worries there. I'm not so sure.
Well, amongst other things, it does presuppose that we have a sharp separation between the mathematical and the non-mathematical, or the abstract and the concrete. And I think when we get to physical, subatomic particles, that becomes very difficult to argue.
Yeah, that's a good point. I mean, I guess I sort of am supposing that the realist view in question does kind of sharply separate the abstract stuff from the non-abstract, but yeah, that could be questioned. Because I don't know if you think that, I mean, of course, this picture is wrong, but if we thought of the universe as a collection of, atoms in the void, it seems to me like, I don't know, you could still have those atoms. Talk of the void might be a little bit more mysterious, but you could at least have those atoms, even if there weren't these mathematical entities apart from them. But it does, as you point out, if it's not so a simple a distinction there between the mathematical or the abstract and the non-abstract, then that might not be so easy to imagine. I mean, of course, there's even some people that think that in some way the world is mathematical, like in some real sense. I'm not really sure what to say about that.
Right. And this is all tied up with ontological relativity.
Yeah, we could move on to that. I did want to ask this kind of, how much of your thinking about the philosophy, like mathematics and philosophy, depends on what the kind of usual semantics is like in normal mathematical discourse, and the presuppositions that people are actually normally making when engaging or thinking in that in mathematical terms. Is that something that is a major concern, or is the theorizing here kind of mostly independent from, like, folk discourse, if that makes sense?
I really haven't thought about it. I'm not sure what your question is, but
yeah, it's all good. I'm just kind of wondering, like, I don't know, it's something that comes up a lot in talk about, like, and I'll go to a different domain, like meta-ethics. When people are, a lot of debate around that concerns, like, what do people normally mean, say, when they use these terms and have thoughts like mathematical thoughts. What kind of presuppositions, what things do they assume when they engage in that sort of discourse? And I wonder if in the mathematical case, like, that's a similar sort of concern. Like, does it really matter what people normally mean when they engage in mathematical discourse, and what assumptions they make in thinking in mathematical terms and so on? To, like, is that something we want to take consideration of when engaging in the philosophy of mathematics, or is it mostly irrelevant? I don't know if that makes it clearer.
There is a movement in the philosophy of mathematics now to pay much more attention to mathematical practice. And it's not clear what the philosophical conclusions from this will be, or how it would affect my views like mine. As far as what ordinary mathematicians say and do, there's a common description, and when they're working, they're Platonists, and then on Sunday when they go to church, they're formalists. So when they're working, they're thinking of the stuff as real. And then when they sit back and wonder, well, how could it be real? It's not in space-time, etc. Then they say, well, maybe it's just a formalism. Is that the kind of thing you're after, or wondering about?
Well, yeah. I mean, that's kind of leading into a worry that I have, which is that, like, what if people's commitments are, like, kind of messy and variable, and, like, you know, they give different answers depending on whether they're just engaging in the practice versus kind of reflecting on the practice, and maybe in different domains of mathematics, people give different answers, or, you know, say things which indicate different sort of commitments. I don't know. It's just a recurring worry for me in like a variety of topics of philosophical relevance, that the discourse and thinking is not as like clear and univocal, like across person and time and place and context, as we sometimes assume it to be. If that makes sense. So yeah, I don't know. Maybe that's sort of what you were suggesting there. Is the worry that I was hinting at?
Well, I think from a kind of Quinean perspective that I have, we have to think of ourselves as dealing with regimented language. And so the kind of thing you're talking about is left behind. As we look at the regimented language, and we try, I guess we try to give them the most favorable, give mathematics the most favorable hearing through regimentation. Nominalism in the 20th century started with Quine and Goodman, who were going to see what we could eliminate from mathematics, whether we could give a nominalistic reconstruction of mathematics. And they were assuming that they were dealing with a regimented language, and they showed how it some of it could be done, but they gave up at a certain point. They weren't able to get as much as they would like. And Quine went on to be more of an anti-nominalist, let's say.
Right. Yeah. I mean, someone might this stuff about the regimentation and the making it like this approach and like the way we kind of regiment our theories to figure out what the existential statements are, and so to figure out what the bound variables are and so on, and to figure out the ontological commitments of our theories. Maybe the worry that I'm getting at is that the actual discourse is not so rigorous, or that's like or at least a lot of actual discourse is not so rigorous, and this approach might be seen as a kind of either stipulation, like here's our kind of rigorous approach, or an idealization maybe. But maybe there's some worries either way, but I don't know. That's the sort of worry that I was getting at there.
Well, that's true. Actual discourse is not, and mathematical thinking by individual mathematicians and mathematical conversation may not be rigorous, and mathematics can make significant progress by non-rigorous use of imagination and development of theories, and then later trying to make it more rigorous.
Yeah, so I do want to also talk about you've written a lot on structuralism in mathematics and defended it in various forms, and so I mean it's a little bit difficult to give a general construal of structuralism, but the kind of main idea is that the focus of mathematical theories, or the object of mathematical theories, is mathematical structures, and mathematical objects either do not exist, or they're like the structures or positions in structures, or maybe the structuralism is ultimately silent on the nature of mathematical objects, at least independent of the structures. The last option is a sort of non-ontological structuralism, which you've moved toward in your thinking of the topic. Can you talk a bit about the different positions here and why you've come to favor a non-ontological structuralism?
Yes. Well, first of all, I think that structuralism should be thought of as a slogan that needs, or may not need, may be just left as a slogan. Okay, that it's saying that mathematics studies patterns or structures, and if you think in those terms, you can think of the development of mathematics as taking a structure and doing something to it. Like, think of the natural number sequence as a one-way sequence of dots. Well, flip it and tack it onto itself, then we've got the negative numbers. But fill in gaps, we have rational numbers. Fill in gaps even more, we have irrational numbers, the real numbers. But the numbers themselves don't have any features or identity except insofar as they're part of that structure. Now that seems to be something that almost all structuralists believe in. And you can find elements of structuralism as early as Gauss, where he was trying to make sense of the complex numbers. He said, well, just think of them as another dimension. And that's, when we started representing the complex numbers as coordinates in a plane instead of on a line. points on a line. Then the next structuralist I know of is Dedekind, and wondering what the natural numbers were, he ended up saying, well, they're a progression. Then he wondered, well, is there any progression? And he offered a kind of a proof that doesn't hold up very well today. He said, look, I have at least one thought. Now I can consider a thought of that thought. Then I can consider a thought of that thought, keep iterating this process, and I have progression. And he argued that when mathematicians come up with a new structure, they basically postulate something that satisfies it. He said, create a new system of objects having that structure. Now, with Dedekind, we have two elements. We have the structure that can be characterized in various ways. And then we have the worry that there may not be anything that has that structure. Call that the vacuity problem. If there isn't anything that has that structure, then all the assertions about it have false antecedents in there, as they say in logic, vacuously true. Conditionals with false antecedents are true. And that's the case in mathematics too. I mean, mathematics has that feature of its logic. All right, in the 20th century, various people have tried to make this more rigorous. And you can have what are called the set theoretic structuralists. They say mathematics is about structure. There are all these structures. But structures are sets. Any structure is a set with some relations on it, but relations themselves can be reduced to sets. Then an issue with that is, well, what about the set theoretic hierarchy itself? What is it? And so you might move on. And another way to approach is there are no mathematical objects, but the physical world has enough in it, enough things and things that are in relationships with each other to instantiate the structures that mathematics talks about. And so the vacuity problem is solved by pointing to the physical world. The problem is that since Hilbert's time, we've been very reluctant to say that there are infinitely many physical objects, or that space is infinitely big as a non-mathematical object. So another way you might approach this is like Stuart Shapiro has, and this is kind of a Dedekind way. He develops a theory of structures. And using the kind of talk I would use, we think of structures as having positions. And then he says, okay, there are positions and there are structures with positions, and then he lays down enough axioms to have rich enough structures for mathematics. And then there's Jeffrey Hellman's approach, which has its roots in Hilary Putnam's paper, Mathematics Without Foundation. He says, all right, for each mathematical theory, I will characterize the theory, its subject matter as a structure, and do so without reference to specific objects, like Dedekind did for the numbers. But then, instead of saying that there is something that has that structure, I will say there could be something that has that structure. He calls himself a modal structuralist. So he basically takes the Dedekind axioms and puts a possibility operator. Say a progression is any set with a relation on it that satisfies certain conditions. The kind of Shapiro approach would say there is such a set and some relations on it satisfying those conditions. The modal structuralist would say it's possible that there is such a set. All right, now that leaves me, and suppose you raise the questions. Well, what are numbers? You can answer that if you take something else for granted. So you could say, well, the numbers are sets, and this is the sets they are, for example. But then you can raise the question in turn, well, what are sets? And you might be able to go further and say, well, sets are objects in a certain category, and use category theory or something like that. But I deny that there's a fact to the matter as to what they are. And that's ontological relativity, relative to taking some ontology as fixed. You can say what other things are in terms of it. And basically, in so doing, the most you can do is preserve structure. So that's where the structuralism comes in. So if you want to say what the numbers are, and you find something else that you feel you understand, whose nature you feel you understand, then you can say, okay, in that something else there is this structure, a progression, and I'm going to identify the numbers with those things. End of story.
Well, just, yeah, good. I mean, you can continue, but just to clarify then, the relevance of the Quine's like ontological relativity here is that there's different things you could say, oh, that's what the numbers are, but there's no like correct answer, so to speak. It's maybe relative to some maybe background ontology or kind of way of carving things up or something like that.
Right. And more broadly, there's no correct answer to what anything is. All you can do is say it's this something else. And then that question can be kind of raised further. What is that thing?
Right. You're never going to get something like, and here's the, well, I mean, you can always have some quote unquote final theory, but that would just be another theory, you know. And you could always say,
Well,
well,
uh,
why not this one?
the the backbone of this is what I call the same size theorem. Uh, Given any theory that's formulated in any one of a broad class of languages, it doesn't have to even be a first order extensional language, but it does have to have a so-called extensional semantics. Anyhow, if that theory has a model at all, if it's consistent and has a model, then it has a model in any domain of the same size. And so if it purports to be a theory of, say, physical objects, it could be reinterpreted as a theory of non-physical objects. And this is ordinarily proved for just first and second order languages that are formulated in an extensional logic, but it can be generalized. If you look at how it's proved, it can be generalized to any theory that has a extensional semantics, like modal logic with the possible world semantics. So it's a very general thing. And of course, Quine doesn't care about non-extensional languages, but that's the basis for, at least for his more recent thinking. And it's always been the basis for my thinking. So if you say, oh yeah, the original theories about physical objects, but not mathematical objects, but you can't reinterpret me because the physical world is out there. I'm talking about tables and chairs. I'm grabbing my chair right now and I'm hanging on to it. You can't tell me that what I'm really doing is talking about a number. But that presupposes theories of meaning that are questionable, or let's say that the Quinean doesn't accept. And you say, yes, you're grabbing your chair, but you're grabbing a collection of chair parts. Or we could take you to be grabbing a collection of chair molecules, or we could take you to be collecting a certain set of numbers that has a certain property. And given the same size theorem, we may be able to recover it and actually specify it.
Oh yeah, so just on your structuralist views now, how much of the conclusions that you draw in like mathematics as a science of patterns would have to be like updated to accommodate your current views? Like would your commitments regarding realism, immanent truth, reference, indispensability, epistemic holism, postulationism, and so on, would that more or less remain unchanged, or how much of your view would change now?
I think it would probably remain unchanged. I might emphasize the ontological structuralism, non-ontological structuralism more, as I have in recent papers. But that book was published in 1997, and therefore it had to be written like in 1995, 1994. What's that, 30 years ago? So
Yeah, just about.
and as I told you in my email, after I retired from teaching, I pursued non-academic work, and I didn't do a lot of philosophical thinking.
Yeah, fair enough. Something about just a kind of clarifying question about structuralism here. Like, on your view, are the mathematical structures, are they not also mathematical entities themselves, or is that like a wrong way to think about it? Like, what is the ontological status of these structures, so to speak?
I think that's a good question, and depends on who you are. I guess if you're Shapiro, you would be saying, yes, they are mathematical entities. That's what mathematics is about. And somebody like Ellen might say, no, mathematics is about what's possible. And it's only claiming that it's possible that there are objects like this, but they might not be mathematical, and they might be something else. They might be space-time points or something. Now, as far as I'm concerned, if you're asking what structures are, you're basically asking for a theory of structures. And you have to have some ontology in which to say that, even if it's an ontology of structures that positions it. And I was never offering that. First of all, because there's no final answer, so to speak, because of ontological relativity. But also, I just didn't think I was mathematician enough to be up to the task. So I didn't think I could give a very insightful mathematical foundation because basically what you're doing is giving another foundation for mathematics that's different from the existing ones.
So, like, yeah, I guess like one way to interpret the question would be like, is there something like sets or something else which is the kind of foundation or another way to describe all the other kind of mathematical structures? Yeah, I mean, I guess maybe the point about ontological relativity is relevant here, which is to say that maybe there might not be much more to say about what structures are, aside from, I don't know, giving other descriptions of the sort of structures you think there are, and maybe what things you think are common between them and so on, or some other way of conceptualizing them like that. I'm not sure, but maybe the question is looking for something that's not like it's the wrong thing to look for or something like that.
Well, again, it depends on whether you're looking for the final answer. I mean, look, geometry can be thought of as a theory of structures. It told us all sorts of things about various kinds of structures: triangles, circles, squares, rectangles, etc. But then model theory, which gives us models of formal languages, can be thought of as the most general theory of structures. But then model theory has to be developed in some background theory, even if it's its own background. I mean, if it just takes the idea of a domain as primitive and a relation on the domain as primitive. But it's usually developed as an applied set theory. So there's really no final answer to these things.
Right. Yeah, fair enough. And then, so when you, given your like non-ontological structuralism here, I take it that your commitment to mathematical entities is kind of largely independent of your commitment to structuralism, so construed. So, I mean, as I understand your point, you're saying that your non-ontological structuralism concerns mathematical structures, and while it employs like devices which appear to commit to mathematical objects, it actually says nothing about those objects, or at least it says nothing about the existence of them independent of those structures in question. I don't know, maybe you can clarify me what I'm getting at here, but could you elaborate on this? And if there were no such objects independent of the structures in question, could we still succeed in referring to mathematical objects?
I think I'm going to reformulate your question. Let's take the question, suppose structuralism is wrong, so suppose somebody points out to me that structuralism is confused in a way, would I give up my mathematical realism? And I'd say no, that I still think there's reason to believe in mathematical objects because I believe in mathematics, and I use it all the time. And my form of indispensability argument is tied up with that. So suppose we even make a further thing. Suppose the indispensability argument is wrong. Somebody can show we can actually dispense with mathematics, and so there's no reason to appeal to the expansibility argument to justify your belief in mathematical objects. And or suppose that Hoffaber and Zuni are right. Mathematics doesn't commit us to the existence of mathematical objects. Would I still believe in mathematical objects? And I think the answer is yes, but because I would still believe in mathematics, just like I still believe in the existence of the chair I'm sitting in, or something. I would still be using it. Now, of course, I guess I could talk myself into another position, but we find ourselves with the beliefs we have, and sometimes it's hard not to. It's hard to give up a belief that you had. I'll tell you, suppose you believe some person is trustworthy, and you believe that for years and years, and then you find out that they betrayed you somehow. It still may be hard to give up your habit and your belief in their trustworthiness. I guess it would be the same for me with mathematics. This is not a very philosophical answer, but I think that's what my answer would be. And that's also why I think my realism as just a personal view is independent of my structuralism.
Right. Good. Yeah. That seems fair. And okay, I did have a question or two on like epistemology in mathematics, and because as many listeners might be aware, this is a common there's certain epistemic worries associated with various realist views in mathematics, and like in that book I mentioned, Vera's Mathematics as a Science of Patterns, you develop some kind of approaches, epistemic approaches to how we think we come to know facts about what structures there are and so on. And of course, you have the additional views about language, postulationalism, which gets around certain words about reference and so on. I was wondering though, like, you seem to have I'm not sure if this is still your view, a fairly, I don't know if this is the right word, but like reserved commitments regarding what sort of structures there are. Because you could imagine someone saying, oh, and this is maybe more of what Shapiro might say, any sort of consistent, coherent structure, if that's possibly realized, that exists. There's a structure of that sort. But I don't know. I think I read you as being a little bit more reserved than that. Is that correct? And what do you think about the dispute there between someone who thinks there's all sorts of structures and someone who thinks there's maybe only a smaller landscape, so to speak?
Well, I do think that I'd have the more reserved view. In Shapiro's theory, he has an axiom: if a description of a structure is coherent or consistent, then there is a structure having that. I would not, other than the fact that it might be hard to say what one means by consistent or coherent in this context, I don't have an objection to that, but I have more confidence in the consistency of arithmetic and the older, more applied mathematics than I do in the more speculative mathematics. Amongst other things, I don't even have much understanding of that. So, but I guess that's too personal a view. But I think we should have more confidence in the older, more tried and true mathematics than in the newer, more speculative. And I wouldn't go so far as to say it's because of conformational holism, but it's more like if you have a tool like a hammer and you've used it for years and years and you know what it can do and what it can't do and what its breaking points are, and then somebody comes along with some kind of new tool, you might not be as confident in its reliability.
Yeah, fair enough. I mean, I could see someone being concerned that how useful these tools are might not be a good guide to which of them have corresponding structures. Because maybe this is coming back to something I brought up earlier, and so you might say similar things. But if the structures exist sort of independently of the world in some respect, anyway, I don't know. Well, I think that the ones which are kind of more useful to us, or which find application in our scientific or mathematical theorizing are, that's more likely that those are the ones that would exist rather than just some other collection, or maybe just anything that might be consistently supposed to be a structure, in some sense of consistently. Yeah, I mean, I guess I'm sort of raising an epistemic worry, but not sure. Yeah.
Well, I think we could put the worry, when you describe something, why should you believe that it exists, or how confident should you be in its existence? And if we want to think of the older branches of mathematics as and attempts to describe something, I think their success gives us more confidence that yes, they did describe something than the newer branches of mathematics.
Yeah, but like what? So I guess I don't know. Like if I have something that's some bit of mathematics, which is not, it's very far removed from describing what the, say, physical world is like, or something like that. I don't know, some like geometry in 1,000 dimensions or infinitely many, whatever. I don't know. Like what it's, I guess the worry is like, why would it's not being appealing to that structure to describe the physical world in this way? The fact that that's not useful be a reason to be more hesitant to think that there in fact is a structure of that sort, I guess, because like I don't know, there's the structures that there are, and some of them might be useful to, it might be useful to appeal to some of them to describe the world, and not others. I guess maybe that's one way to put the worry.
Well, I don't think I would put it in terms of describing the world, if by that you mean the non-mathematical world, because a lot of the structures in mathematics have been developed to describe other mathematical structures or describe what's going on in other branches of mathematics. It's just that in the higher reaches of set theory, that there's more disconnect between what they're doing, what the claims that are being made there, and anything at a lower level.
Right. Yeah, fair enough. I mean, I could probably say more about this. Well, obviously, there's a lot of stuff to worth exploring here, but I do want to ask a couple questions about logic, and don't want to keep you too long. So move on to that. Yeah. So you've written on the normativity versus descriptivity of logic. So it's a bit difficult to state exactly the distinction, but like on a normative view, right, logic has to do with things like principles of correct or right reasoning, or how we should update our beliefs, and things of that sort. On a descriptive view, it has to do with more like descriptive facts about sentences and the like, such as what inference rules invariably preserve truth, or whether there's a sentence and its negation which are ever both true, and so on. Yeah, so I mean, could you talk a bit about your take on the normativity versus descriptivity of logic?
Yes, of course, that the beginning paper, Is Logic Normative or Descriptive, was written back in the 1980s, and my views did evolve a lot. But I had been prompted by some writings by philosophers and decision theorists that were paying attention to how people actually reasoned, they said, and they would give tests like, I'm going to you're giving some information and then about some cards, and then you're going to turn up the next card, and people would give a different answer than if they had been using deductive logic correctly, or the gambler's fallacy. I got to win because I've been losing for such a long time. And there were people who were arguing that we ought to design our logic to reflect this. And I was arguing against those people. So when I said logic was normative, I was thinking logic is not a branch of psychology. Now, since then, I've made a distinction between what I call logic in capital letters and logic in lowercase letters. And logic in capital letters is a discipline that logicians practice. And logic in little letters is our inferential practice that we, as everyday people, use. And big logic, capital letter logic, may or may not be attempting to describe lowercase logic, and it may or may not be attempting to tell people how they ought to reason. I used to have students who wanted to take my logic course because they thought it was good for law school, thought it would teach them to think better. I think that my straight philosophy courses, where we had to analyze arguments of philosophers and say what their premises and conclusions were, and find fault with their arguments, were much better preparation for law school or to be a lawyer than just regular logic course. But anyhow, so I don't think that logic with the capital letters is a branch of psychology. So the question is, how does it proceed? Well, it can proceed as a purely mathematical thing. You can say there are statements that have truth values, or there are propositions that stand in certain kinds of relationships, and try to develop criteria for determining what those relationships are, like truth functional validity and the truth table test. So that would be kind of a descriptive pursuit, and it would be basically applied mathematics. Then you could also look at it as more normatively, in the sense of trying to say what good arguments are. And, we say a good argument is one where the premises imply the conclusion, where we've used logic, capital logic, in the descriptive sense to say what implication is. But there's another another step. Why is an argument where the premises imply the conclusion good? That's when we're doing something normative. These, I guess, are probably conflated by logicians when they write logic textbooks and so forth. Some just do it as part of mathematics. Others, when they write, especially an elementary text, trying to convince students there's a reason for studying it, say, well, you want to know what a good argument is. But where the normative thing seems to have more bite is in statistics and decision theory, where we want to know what is a good randomized clinical study, and then we get into descriptive. We do math, but we also bring up normative questions. Why should we set the significance level at the 0.05 level? So I may have lost your original question, but I agree. Logic is in some sense descriptive and in some sense normative, but it's not a branch of psychology. Where it's descriptive, it's more like a branch of mathematics. And where it's normative, it's more like, I don't know what you call it, applied ethics or something.
Yeah, that seems like a fair breakdown of it. There's the aspects of psychology we might be interested in, like, well, how do people tend to reason and so on, and there's some connection to logic there, but I guess you want to say that's not really the domain of logic as a field. That's maybe something else. And in logic, we're either looking at these sort of descriptive stuff or things, or something more normative like that. And that gets a bit tricky of how to break down that normative category. But yeah, a lot of it may have to do with decision theoretic stuff, means end reasoning sort of stuff. But then there's more general things like, I don't know, these notions of good arguments and, having consistent beliefs and so on. I guess, yeah, but these are they're legitimate understandings of logic, I guess. And maybe just what happens here is that because there's a bunch of things that are like relevant to logic and discussion of logic, they sometimes just get tied together when people are discussing logic. The normative stuff, the descriptive stuff, and sometimes it can get like a little bit unclear what the actual kind of focus of logic is supposed to be, because there's a bunch of things that are relevant to it.
Right.
I don't know, I'm just kind of thinking out loud. I did want to ask about your because you've had a definitive view, which you call, logical anti-realism, or you argue against logical realism, where logical realism is the view that, roughly there's various like logical truths that hold independently of us and our psychology and linguistic conventions and inferential practices and the like. So, I mean, you could expand on this, I guess, but I would agree, I guess, that logical truths are in some respects dependent on, like, at least certain linguistic conventions, like what would be regarded as propositional, and how the truth values of propositions are fixed, and the meanings of various terms and connectives in our logical vocabulary. Is would this commit me to sort of logical anti-realism, or is like anti-realism saying something stronger than this, would you say?
I believe it's a stronger position. First of all, we have to distinguish individual sentences such as 0 is less than 1 or 0 is not less than 1, and claims about all sentences of the form P or not P are true, and further claims such as all propositions of the form P or not P are true. And where the logical realism comes in is not with respect to anything I said, but the sentence 0 is less than 1 or 0 is not less than 1 is a logical truth. It's logically true. And that fact is independent of our beliefs in psychology and our linguistic practices and all those other things we enumerated. And the same for it's logically true that for all propositions P or not P, or it's logically true that for no proposition P is P and not P true. Or just, you could leave the true off. It's have another way of asserting these general things. And the way I got into this was that I was looking at Hartree Field and Jeff Hellman, who introduced logical necessity and logical possibility operators into their foundations for mathematics. And they wanted to be realists in the sense that they wanted those claims to be objectively true, that at least in the sense of being independent. And I thought that was making presuppositions that were just as questionable as the presuppositions about mathematics that mathematical realists made, and they were denying, and for much the same reason. We can know that 0 is less than 1 or 0 is not less than 1. We can know that 0 is less than 1 and 0, rather, it's not the case that 0 is less than 1 and 0 is not less than 1. We can know those things. We can assert they're true. We can assert under a wide variety of sentences and circumstances a sentence of the form P and not P is not going to be true, will be false. But we're not going so far to say that it's a logical truth and it's independent of us. Now, there are questions. How do we know that 0 is less than 1 or 0 isn't less than 1? That might be like asking, how do we know that 1 plus 1 equals 2. And maybe all I can say is, well, I don't know how we know, but I know it, and I rely on it. You know, or I can definitely give you a mathematical justification for it, but that's just going to push the question back further.
Right. Yeah, and then here, as I understand it, you've actually is even more radical than this in some way. Like, you describe your view as a sort of logical non-cognitivism. That logical utterances aren't really claims in the usual sense anyway, but they serve certain non-cognitive functions, for example, to communicate some reaction or expectation to inferential practices. Is this appropriate characterization of your view? And maybe if you could expand on it a bit. And in particular, I was wondering, how would we account for the apparently ubiquitous assumption of cognitivism in like everyday logical discourse?
Well, let me answer the first part of your question, and that is yes, it would. I could have given my anti-realism about logical matters and just stayed silent about the rest. But we do use statements like, you just contradicted yourself, or he doesn't pay attention to the implications of his views. And that appears to be a way of using logical terms in a realist way. Now, when we say he just contradicted himself, that could just mean he just said one thing and then denied it. And that would not make me be a realist about logical contradictingness or logical impossibility. But when we say he doesn't recognize the implications of his views, well, that might be a little harder to unpack. But we do have this practice. For example, if I tell you all my friends are very trustworthy, and introduce you to this person, and he turns out and say, this is a very good friend of mine, you infer he's trustworthy, and then you trust him with something and he lets you down. Then you'd say, I didn't recognize one of the implications of my view, or something like that. I'm not sure how I would unpack that yet.
Yeah. I don't know if I'm going to say more on that, but I don't know. It's a bit tricky because I mean, it feels to me that we could give, cognitivist interpretations of those claims. I'm not so sure why I would be suspicious of that, I guess, but I don't know. I guess I don't know. It's just a consequence of your. I guess I'm just wondering what the kind of main motivation is for this sort of non-cognitivism.
Well, because it seems to be, if you're not a realist, then you have to have some alternative. And I don't want to be a relativist. I mean, I don't want to say relative to my logic or something. It's true that there's never a case where P and not P. And so I had to have some kind of an account. And this seemed to me like an attractive beginning.
Yeah. Yeah, fair enough. I did want to tie this to the mathematical stuff because, I mean, you mentioned like logical necessity, and because like there's a fair amount of people who believe in mathematical objects and other abstracta will want to say that these things they exist necessarily, if they exist at all. Perhaps of logical necessity, perhaps of some other sort. But I take it, given the stuff you've said about logic, that you'd be suspicious of that claim, that sort of talk in the first place. I don't know, what do you make of that? Those sorts of claims that people make about them existing necessarily?
Well, I just wouldn't use that talk to begin with. So, I wouldn't say, well, they don't exist necessarily. They exist continuously. I just would say, I can't make sense of that, or I'm not going to talk that way. And if somebody writes a preface, say, to his philosophy of mathematics, and he says, one of the things I have to account for is the necessity of mathematics and the necessary existence of mathematical objects, I'm just going to ignore that unless I'm, trying to write a review and I want to see how well he defended, how well he achieved his goals. But from a strict personal philosophical point of view, I'm just not going to pay much attention to it.
All right. Yeah, I don't want to keep you all day, but it's been great. I do normally like end with kind of more general meta philosophical question, if that's all right, and then we can finish up. So yeah, what would you say is the to you, or more generally, the value of philosophy? Why is it worth doing? Perhaps to yourself and more generally, and maybe philosophy of math in particular. I don't know, maybe what you think about this question.
Well, first of all, from a purely personal point of view, it's interesting. There are questions that I found very interesting and they drew my attention. More generally, I think that philosophy is very useful in getting you to think about abstract problems and to think clearly, and to try to get clear on things that may be very vague and recognize that they're vague and recognize what steps might be taken to clarify the questions, or recognize that they have to be left as they are. But I'm not sure when I'm thinking about what's wrong with a car or what's wrong with somebody's philosophical theory, that I'm using a process that's all that different from the one to the other. even though the subject matter is different. But I've enjoyed this conversation. And I thank you very much for having me.
Yeah. It's been really great having you. Thanks so much for coming on.
And also for just in preparing to talk with you, I had to start thinking about these things that I hadn't been thinking about in a long time, and I'm glad that I had that chance too.
Yeah, that's great. Yeah, it's fun stuff to think about. But yeah, thanks again for being here and taking my questions and giving your thoughtful responses. It's been great having you, Professor Resnik.
Well, thank you.